Welcome to Eccentric Mold and Engineering's 2017 webinar series. If you are here for design considerations to successfully manufacture complex overmolds, then you're in the right place. We welcome both customers and future customers to learning about how to successfully design your overmold project. My name is Brian Graves, and I will be your host for this session. A few things to cover before I turn over the webinar to our keynote speaker. This presentation is expected to last approximately 20 minutes. Afterward, we will hold a question and answer session based on the questions you've submitted. So, during the presentation, feel free to submit your questions using the chat function located in the lower right of the control panel. We will have time to answer just a few of those questions. If we run out of time before all those questions are answered, we'll follow up by sending you an email containing those answers as well as a link to the recorded version of this webinar for future reference. With that, I will now turn over the webinar to our keynote speaker, Steve Schlehuber.
Good afternoon, everyone. My name is Steve Schlehuber, and it's my pleasure to present you with the information for this webinar where we will be talking about the overmolding process and what that means for time to market when it comes to your design. I work with many designers and engineers daily, and we discuss the design intent for an overmolding process on their product all the time. For years, I've been on the ground floor seeing the overmold design process come to life, so we're going to get started. All right, so the first thing is we're gonna label out what the agenda is. The first thing is we'll talk and kind of define what is overmolding. Talk about that process, why we do it. Excuse me. The second thing is we're going to talk about complex overmold examples. I want to show you some of the different types of overmolding that we've seen and talk through each one of those designs and actually look at some parts as well. We'll talk feature specifications. We want to talk about what are some of the important things. We talk with designers and engineers about what we should see in that specific design. We'll also talk material evaluation, a very important part of the overmolding process. We'll talk substrate inefficiencies. This is actually something that's different from the first webinar. If you did attend the first overmolding webinar that we did, we want to incorporate this in because it's an important part of what we see in a final part. We'll talk surface finishes. This is a small but important thing to remember. And we'll also talk file preparation and why that's important in this process. So what is overmolding? A simple definition is it's a two-shot process of combining one shot with another to give you one final assembly or one final part. And what that entails is your first shot, which is a substrate. This is typically a rigid material. It's a harder plastic, and what you want to do is incorporate a design intent into that substrate to give you a second shot, which is an overmold. And typically this is a rubber. And rubber-based plastics are such as TPEs, TPUs, TPVs. Sometimes we do see that people will actually use another substrate that is a little bit more rigid material to actually overmold onto another rigid material. But the majority of the time we're using softer plastics on top of a harder plastic, and as you can see on the right, that gives us one solid part. So what we want to do now is I want to list out 3 different examples that we have for a complex overmolded part. The first one is connecting 2 or more substrates. This is where we take 2 rigid substrates, and this is actually kind of considered a 3-shot process. We mold or shoot 2 different substrates that are rigid, and we actually connect those or build an assembly of one part using a softer plastic or rubber material. Typically we see this in like a button or something where we can't have the 2 substrates rubbing together, so we throw that rubber material in between the 2 of them, or we can do a sealing process by doing that as well. The second is a cosmetic or aesthetic detail. A lot of times people have a product, they have a part, it's just not doing it for them. They want to add something in that's going to pop. It's going to be a different color. On the screen you can actually see one that has a red and black, very stark contrast between the 2 of them. And essentially what they want to do with it is make it stand out from their competitor's part. They want something that looks different, it looks cool, it's something that they can be proud of in their final design, so they want that cosmetic approach to it. The third portion is tactile. This is touch, it's feel. They have a handle or they have some type of assembly that they're doing where it's going to be in the hands of their customer, or maybe they're doing like a beta testing or something like that, and they want to have some type of different feel other than a cold, rigid plastic. So they'll put that rubber over top of that handle or that grip, or whether it's a button. They just want it to feel different in the consumer's hands, so they're going to add that into the process. So now we've gone over a couple of different examples, and what I want to do is actually show you guys a couple of different parts that are going to kind of speak to what we just talked about. All right, so this first one that we have here, this is actually the first example that we talked about. This is where we're taking two rigid substrates and we're actually molding them together by using a rubber material. So we actually have a housing right here. This green portion is a rigid substrate or a housing, and then we have this red portion right here. This is actually a rigid substrate. That's a button. And what we've actually done with this one, let me see if I can get this over. This blue portion underneath here actually is a rubber material. And what we did is we came through the bottom and we actually subgated underneath this housing. Came in from the opposite side of the tooling that you normally see a gate, and we filled in this complete area around the button to connect in with the housing. And as you can see, there's a little actuator portion of the button right here, and on the front side, when they push on this button, it actually moves freely in between, so you don't have friction between substrate and substrate. It allows for just enough pressure, and it's a very cool look. It's a very cool thing that is accompanied with this assembly. Worked very well. This was a good application. All right. The second one that we're going to look at here, this actually has a very functional overmold. The green portion that you see right here, this is going to be your rigid substrate. That's molded with a harder plastic. And then on the inside, we actually have two different areas that are actually separate from each other that have a thin layer of rubber. And what this is actually designed to do is grip onto something. It's designed to hold something in place, keep it from moving. So this has not only a feel portion, but it actually has a very mechanical property to it. The product designer that was developing this had something in mind. They knew that a rigid material would just not hold as well unless they had this rubber material on it. So that, as you can see, move it all the way around, two separate entities of rubber on one part. All right, now we have another part here. This is actually a housing piece that has this portion right here that I'm highlighting. This is the actual substrate. It's a very hard material. And then on the outside, we have, essentially this is like a bumper for this part. They've designed in this overmold part that goes all the way around this part. As you can see, it's got shut off right on the bottom here, only goes so far. And literally this is designed so that when this housing goes together, it creates just an extra feature. This could be aesthetic, this could be a cosmetic feature as well, just to add in something that looks different. But also it blocks the parting line that goes all the way around this part, makes it look very clean and seamless. This could have a couple of different functions as far as how this part is used in the end product. All right, so now that we've shown a couple of the examples, we want to talk about some of the design considerations for your overmolding process. This is where we get into some of the meat and potatoes of thinking up these designs and what's involved. First thing we're going to talk about is material evaluation. Extremely important to consider. We want to look at the feature specifications, we're going to look at surface finish, and then file preparation. So for the first one, we're going to actually start talking about some of the feature specifications that we have. And we're going to talk first about wall thickness and why that's really important. So we're actually going to go back to the parts. I have one last part to show you. And you saw a cross-section of a view of a part that was up on the slide, and this is the actual part that comes from. This is actual piece to a handle assembly, and this gray portion right here, this is the overmold. It's completely wrapped all the way around the substrate, and this is very tactile. This is a grip. This is all touch. This is so that when they hold this handle in place, it's gripping onto their hand, and this is going to be your substrate that flows all the way through this piece. Okay, so we're going to go back now to the slide, and as you guys can see on the screen right here, in that cross-section view, we can actually see that this part has a very nominal wall thickness all the way around. And that's very important when considering some of the features in the design process to make sure that we have good flow with the material. You have to remember that this material is going to be flowing over a very cold substrate. So that substrate sitting on the table, it's going into the tool. You have to give it every chance it possibly can. You don't want thick to thin, you don't want thin to thick sections within your overmold. You want to make sure it's very nominal all the way to the end of the part. The best practice is really to be consistent with both the substrate and the overmold. The minimum requirements, you want to make sure you're not leaving any very thin areas that could be problematic. Radii is also a big issue that we see a lot. I always like to use the example that material flows through a mold just kind of like water. And if you picture water flowing through two different types of pipes, one going down a 90-degree angle that has very hard and right angles on it, that water is not going to flow very easy. It's going to hit those right angles, it's going to bounce all around, it's not going to have the speed of flowing through if you had to take a pipe that had very smooth corners on it. When that water flows, it goes very fast. I always think of PVC piping. If you picture material going through a mold just like you would picture water going through that pipe, it goes around that corner, it goes very fast, efficiently, it gets to its end point much quicker than what it would if you have sharp corners and that sort of thing. So in this little illustration that you see on the page, we use rounded corners or radii on the edges as much as we can on both the substrate and the overmold. And what that does is just it's not just flowing through the overmold, but it's also flowing over top of the surface on the actual substrate. You have to remember that your substrate is going to become part of the tool. Don't think of it as just a part. That's going to be held in place by cavity and core. It's not going to move, just like your tool won't move. It has to be considered part of the tool. And just like you would add that into a normal substrate design, you have to make sure you do that as well on the overmold. All right, when we talk about gating, this is important as well. You want to make sure that you have a clear way to gate into the overmold material. A lot of people will take a housing and they'll place an overmold section, somewhere in the middle of that housing, and they don't leave anywhere to try to access that for our gating purposes. So as you can see on the right, sometimes the best thing that you can do is you can put a hole right through your substrate and you can subgate into the bottom of it. This can also double as a mechanical hold, but a lot of times you want to make sure that you have good, clear access to that overmolded portion. And if you can't get to it, a lot of times what people will want to do is they'll want to put 1, 2, 3, 4 different locations on an actual substrate that they want that overmold material. However, they're not connected. Well, if you go underneath the surface, under the back side of that substrate, you can connect them all that way, where it can't be seen on the outside of the part. Create a little landing pad that we can gate into, and we'll make sure that we reach all those different areas on it. So gating is very, very good. All right, shutoffs, this is very important as well. Shutoffs is everything when it comes to the integrity and the overall look of your part. You want to make sure that you have hard shutoffs. No knife edges, no feathered out areas. Those create very difficult molding situations, and we can get air trapping, we can get gassing. Any thin area is usually hard to fill, but especially on an overmolded part. You want to make sure that nominal wall thickness stays clean all the way to the end of that overmolded part. And that's going to make sure that we can get hard shutoff on the substrate with cavity and core and we can push that material right up to the end to get a good fill. What happens is if you create an area that's hard to fill, then we're going to have to pack it. We're going to have to put more pressure. We're going to have to make sure that we're going outside of the parameters that's good for that material, and that can create flashing, and ultimately it's just going to make your part not look as good as what you intended for it. So you just want to make sure you get hard shutoffs, let the cavity and core do their job on top of that substrate. All right, material evaluation. This is important as well. You have to make sure that you pick the right material. Make sure it's one that takes a good bond or adhesion. ABS, PC ABS, PC. There are some nylons out there. You just want to make sure that the material does not have much lubricity to it. Because the tough materials, those are the ones that have some type of lubricity. Polypropylenes, HDPE, LDPE, acetals or acetals. These are all materials that can have a really hard time gripping onto that rubber or that soft plastic that's being used. For the second shot, you can actually go straight to the data sheets and start looking at rubber materials, TPEs, TPUs, TPVs. The data sheet will specifically tell you exactly what type of material to use. Some of these will actually bond and hold on to the substrate materials. The last thing you want is for your overmold to start peeling off or coming off in the hands of prospective client or consumer or whoever might be handling this part. You want to make sure it's going to stick as hard as it possibly can. Making sure that you have the right second shot material, that's the most important. So one of the last things we're going to talk about is substrate inefficiencies. Consistency in the overmolding process relies on a good substrate. We can't emphasize that enough. Your substrate design is very critical. Any defects we see in that molding process of the substrate are going to be very evident when it comes to the overmolding process. Warp parts, they can fault your shutoff on the overmolding. So if you have warping or inconsistencies where we will be shutting off on the substrate, that overmold material is going to find its way to those inefficiencies very, very quickly, and it's going to create flash or a different looking overmolded part. We also see inconsistent shrink on substrates. When we don't use the right material, we can get irregular substrate sizes. And what that does is going to make shot-to-shot repeatability very hard. And this comes down to processing that substrate. If we can't process it effectively, we cannot create a good overmold process. We will consistently get more flash on some parts than others. Concentricity also matters. If you have round parts that you're overmolding, you have to make sure you talk with your molder about how to keep that part concentric. Because when it goes into the tool, it has to stay the same every single time, or you'll get inefficiency on your overmolding process. They can be problematic if you get oblong or oval parts when they're supposed to be centered. All right, quickly we'll go through surface finishes. Don't expect a polish on your overmolded feature. It's going to be a B3 or a blasted finish, and the reason is polishes stick. They want to stick to the tool and not your part. You don't want them to be battling out to which it's going to stick to. You want it to have the advantage of sticking to your part. That's why we put a blast on the tool, so it breaks up the surface and doesn't want to stick to it. Ultimately, you have to keep the integrity of your part. You have to make sure your overmold will stick on to the substrate. And one of the last things we'll talk about is file prep. We want to make sure that you design your substrate first with the intent of your overmolding going with it, but design that substrate so it's a very well-designed substrate so we get a good process substrate. Then design in your overmold separately. Keep them two separate bodies. That's how, I tell my designers and engineers all the time, that's how I evaluate. I look at them as two separate files so that we can actually see if there's inefficiencies between the two and then look at them together. So always keep that in mind. Design them as two separate parts and then merge them together. All right, so for the summary and things of key points to keep in touch, evaluate the materials. Do your research, talk with material suppliers, check the data sheets, make sure you have the right substrate material that's going to work with the right TPE material. Treat overmolds as a separate part. make sure that your overmold has a good wall thickness. Make sure it has radii to allow for that material to flow well. Make sure you design flow channels or mechanical holds if you're not able to use the right TPE material. Also, use accent grooves, hard shutoffs. We want to make sure that that cavity and core presses very hard against the substrate. We don't want flash that ruins the integrity of the design. Remember, for surface finishes, B3 or a blast, you want to prevent any type of sticking, so don't expect to have that polished. And then also for the files, just make sure we keep 3 separate files, 1 assembly, 1 substrate, 1 overmold, and make sure you keep that intent throughout the entire design process for it. And design it as you dream it. You know, the right manufacturer will make it come to life. Keep these things in mind. Make sure you keep the integrity of your substrate design and your overmold design, and ultimately you're going to get a part that you're very satisfied with.
Great, thank you, Steve. We now open it up to the question and answer section. Feel free to submit your questions. We have one here. Can you overmold clear PC and get optically clear results both in finish and clarity in the lens? What do you think about that, Steve?
Well, I can say this. We've overmolded onto a lot of PC materials, a lot of optically clear materials. When it comes down to the actual overmold material, the problem that you're going to find is that when we talk about the surface finishes, you can't get a polish on that actual overmold material. And the issue with that is it's not going to leave the same type of clarity that you're going to have on a PC material that's polished. So ultimately, the area that's overmolded is not going to have the same clarity that you're going to have on a rigid part that you're able to polish. Like we said before, we don't want it sticking on to the tool. We want it to stick onto the actual substrate.
Okay. We have another question here, which is for gating, is the core side the most common for gate location? Are there situations where you cannot gate from the core side?
That's a good question. And I will say this, when it comes to overmolding, we use a lot of different types of gates. It can all really depend on the type of assembly that we have. And as I mentioned before, a common method that we use is subgating. So we will still come in from the same side of the tool, but we can actually subgate underneath into the opposite side of the tool, into the cavity area, so that we can come back up through the substrate part and gate where you can't be seen on the cosmetic surface. So there's some really tricky ways in which we can try to gate for overmolding. They're not always your most standard methods. So yeah, there is ways to gate from the opposite side so that you're not always forcing that gate location onto a show surface, because we get that a lot of the overmolding is for show.
Okay, another question in here from Joseph. Is 8/100ths thick substrate and 5/100ths thick rubber acceptable wall thickness?
80 thousandths is actually a pretty good nominal thickness for a substrate, depending on the material. But for most materials, that's actually a fairly good amount. I would say 50, depending on how much surface area you're covering. A lot of times that can depict more than just the overall thickness of the substrate. If you have a large portion that you're covering with that actual material, you may want to go thicker than 50 thousandths. But ultimately, you want to make sure that you're able to cover that entire span. So you may need to move it from 50 to 60 or even up to 70 thousandths of an inch thick so that you can make sure you're getting to the right amount of thickness, or make sure you're filling the part as well as you possibly can.
Okay, great. That will conclude the question and answer section. We'd like to thank you for joining our webinar, Eccentric Mold and Engineering. If you have any questions or interest in eccentric products, please visit our website, our social channels, or contact us directly at the number or email listed on your screen. And remember, a recorded version of this webinar along with the answers to all the questions will be sent within 48 hours. Thank you. We'll be signing off in 3, 2, 1.